11.2 does more than talk about different shapes. We're also going to talk about the symmetry that those shapes might have. There are actually three types of symmetry. The one that most people remember is line symmetry. So we'll start there. Line symmetry is basically when you can take the shape, fold it, and it will fold on top of itself. The fancy way to say it is our definition here. A figure has line symmetry if it's its own image under a reflection of the line. So what I have in these blue dotted lines are our lines of reflection, or our reflection line. If I imagine taking this shape and folding it along this blue line, everything would match up perfectly. It might be easiest to see in our boat down here on picture D. If I fold along this middle, the boat would fold in on itself. This is similar to activities that are done in the classroom where you take paint and you squeeze it on a paper and then you squish the paint over and fold it. And when you unfold it, you get a butterfly shape. You can have multiple lines of symmetry, like our star here. You can have one line of symmetry, or sometimes you won't have any at all. So here's some other shapes here. We can practice drawing the lines of symmetry for each one of these. For my first one, I actually have 6 lines of symmetry. Sometimes with these, it's best to think about going to the angles and the lines. Most people just see the line ones. If you missed some, you probably got the ones in the middle of the lines, but not the angles. So the midpoint of each one of the sides, and then if you look the midpoint of each angle, that's going to give you 3 more. So 3 from the sides and 3 from the angles are my 6 lines. B only has 1 line of symmetry. I can only fold it down that vertical line. This C shape actually has 2. I can fold it long ways or short ways. And Z is not going to have any lines of symmetry. If I were to fold it over on a vertical line, on a horizontal line, these diagonals are going to mess up and not be on top of each other. And the same thing for the vertical. If I were to fold it over on the vertical, this diagonal line messes up. So we could have no lines of symmetry. My second type of symmetry is rotational symmetry. So it's where we take a shape and we imagine it pinning it in the middle, like a wheel, and turning the shape around. If it would end up on itself, it has rotational symmetry, and if it wouldn't, then it does not have rotational symmetry. The definition is a little long, and it gets a little nitpicky. We say a figure has a rotational symmetry when the figure can be rotated less than 360 degrees. The reason that's important is because if you rotated it all the way to 360 degrees, you would be back on yourself. And that's really not rotational symmetry. Anything's going to end up back on itself if we go all the way around a circle. So if we look at this flower, there's 1, 2, 3, 4, 5 parts to this shape. So I'm going to take my 360 and divide by 5. That's going to tell me my rotational turn is 72 degrees. If I took my first petal here and turned it 72 degrees, it would end up right here. The next step is to write out what all the turns are. And we're counting by 72. So it's 72. If I add another one, that's 144. Another is 216. And last, I would have 288. Don't count the 360. Because remember, our definition says it has to be less than 360. Let's do B. There are 1, 2, 3, 4 parts. So now I'm going to divide 360 by 4. That gives me 90 degrees. What degree we're more comfortable with? So my answer would be 90 degrees, 180, and 270. Again, don't write 360 in your answer. It's a little bit harder to see the parts for C and D. That's because you just have your top part and your bottom part. So we say it just has 180 rotational symmetry. That's because there's 1, 2 parts. So 360 divided by 2 is 180. And the same thing for D. I've got 1 part and 2 parts. So 360 divided by 2 is 180. All right, let's try a couple more. So here are two more shapes. If you want to pause it and try them, you can. For this first one, there's 1, 2, 3, 4, 5, 6 parts. So I'm going to divide by 60. So my answer is 60, 120, 180, 240, and 300. Notice that all the examples I've done, my answer has one less answer than the number of parts. 1, 2, 3, 4, 5. And you can see that in the ones we did previous. That's because I don't include 360 in my answer. This second one gives people a little bit of trouble. It does have two parts that I tried to highlight here. This part, kind of on the top rightish, is the same as on the bottom left. So it does have two parts. I'm going to do that 360 divided by 2. Just like C and D we saw in the last problem. So my answer was just 180. That brings us to our last type of symmetry, point symmetry. And point symmetry is a special type of rotational symmetry. Any shape that has 180 degrees in its answer for rotational symmetry has point symmetry. So there's no extra work to do. You can see these are all examples of shapes that have point symmetry. If we go back to the pictures we were originally looking at with rotational symmetry, we can see the ones that would have point as well. So if we go back to our first 4 shapes and look at their answers, B has point symmetry because it has 180 degrees in its listed answer. A did not have it, so it does not have point symmetry. C and D, in fact, their only answers were 180, so they also had point symmetry. Point symmetry is just a special form of rotational symmetry.